All right, hey, little review on electron configurations. I need my black marker though. Hey, I'll be right, there it is. I'm sure a lot of you guys remember this from your first year course, but I thought we should review it. Then we'll go more into we'll do the Bohr model and some electron configurations. But a little periodic table up here. And let's first start by looking at the different areas of the periodic table. There's basically 4 areas. This area here, this here, this, and then this group down here. So the alkali metals and the alkaline earths, they have electrons in what's called the S block. This is the S block. So it's an S orbital, which is a spherical orbital. Here, notice there's just 2 groups. Here there's 1, 2, 3, 4, 5, 6 groups, or 6 families. And these outer electrons are in the P orbital. I think you saw the shape of those in a recent video. And then here there's 10 families in the transition with the transition metals, and this is the D. These valence electrons are in the D block, and then here, and these actually belong right in between here. So after lanthanum, you'd have this group that starts with this, period. That group that starts with cerium, and this is thorium. So this is the F block, or these electrons would be in the F orbital. Okay, so let's write some electron configurations. I'm going to write them down here. So if we look at hydrogen has 1 electron. So we would write 1s1. Now there's a lot to kind of unpack here. That's the energy level, that's the type of orbital, and that's the number of electrons. Okay, so 1s1, it gives an address to that electron. If we drew, okay, we'll do a Bohr models later. So let's look at helium. Of course, would have 2 electrons, and so helium would be 1s2. It would fill that s orbital. S orbitals can only hold 2 electrons. All right, let's go over to something like nitrogen, and let's look at the electron configuration of nitrogen. So nitrogen has 7 electrons. So what I'd like to do is just use the noble gas abbreviation. So let's start at the noble gas that comes right before the nitrogen. So we look at nitrogen, noble gas right before nitrogen. These are the noble gases. Is helium. So we put helium in brackets. So we've already counted for these the 2 electrons. So then what we can do is, using the periodic table, start here. So we'll start here, and this would be let me just label this 1, 2, 3, 4, 5, 6, 7. This would start the 2nd energy level, and of course there on the 2nd energy level there's an s orbital, and there would be 2 electrons in that s orbital. Now we've accounted for 4 electrons, and now we go and follow this, and now we're in the 2p orbital. There's no p orbital in the 1st energy level, just an s orbital, and we'd have 1, 2, 3 electrons. So just make sure you count up the electrons. There should be 7. So that would be that. Let me show you right now what would happen if we want to draw the electron configuration for the nitride ion. Nitride's -3. Of course, that would mean we'd add 3 electrons. You just add it to the last orbital. So then we would have 2p6. So we just added 3. We filled that 2p orbital. In fact, we filled that whole orbital. And now it has the same electron configuration. It has the same number of electrons as another atom. And which atom would that be? Right, neon. So we would say that they're isoelectronic. N-3 and neon are isoelectronic. Same electronic. Same number of electrons. Okay? All right. Hey, if we look at, let's go back to, the blue's hard to erase. Let's go back to nitrogen for a second. I want to teach you one more thing. Nitrogen. So this 2p orbital, if you draw the orbital notation, which you typically don't have to, these boxes represent the 3p orbitals. One is in this plane. Oh, sorry. One is in this plane, and the other is in the z plane. So this would be coming in and out of the board or the wall. And you don't forget what we used to call in 10th grade the bus rule. You just want to sit by yourself until you have to double up. So this is how we would represent the orbital notation for nitrogen. It's actually not the bus. The fancy name is called Hund's rule. Hund's rule. You can think of it as the bus rule. So don't double up until you have to. So what would this be? That would be, if we add another electron, that would be, oxygen. That would be fluorine, right? And then, of course, we'd have neon. All right, let's look at another one. Let's look at a guy in here somewhere. Let's look at zinc. Zinc's right here. Has 30. All right, zinc has 30 electrons. I have a periodic table over here that I'm using just to make sure I have the atomic number correct. So atomic number tells us it has 30 electrons. So let's use a noble gas. So let's look at what's the noble gas that comes right before zinc. So we go backwards, it's argon. So we got argon. So we've already accounted for 18 electrons. So that's kind of nice. So let's just start from here. So if we go back, if we go over here, now we're right here on the 4th energy level. We have to go through the S block. We have to go through the S block before we can get to the D. So it's 4s2, and then 3d. Okay, so how many electrons can d orbitals hold? There's 5 d orbitals. There's 5 different types of d orbitals. Each can hold 2. 5 times 2, 10. So that's zinc. All right, that is zinc. All right, why did I choose zinc? I wanted to show you what happens if we have the zinc ion. Of course, we know that we lose 2 electrons. So which 2 are we going to lose? Well, we're going to lose these. The ones on the higher energy level. They're further from the nucleus, so they're more easily plucked off, okay? So always, when you have a cation, always remove electrons from the highest energy level before you go into an inner energy level. Okay, let's do one more. Let's go through the F block and just show you how that works. So I typically like let's do lead, which is, lead is right here. Lead. I'm hoping you can see this down here. Lead has 82 electrons. All right, let's use the noble gas abbreviation. What noble gas comes right before lead? And that would be xenon, right? Xenon. Xenon has a lot of electrons. It's got 54. We're good. All right, so then we go over here. We're here. 6s2. All right, now, what happens here is, so after lanthanum, what would happen is we would go into this F block, and this would be 4F, and this is 5F. Okay, how do we remember that? It's, the F block is always 2 less than the row. The D block, this is 3D, 4D, it's 1 less than the row it's on, the period that it's on, the period number, we could say. So what we can do is we know it's 4f. All right, how many electrons can the f orbital hold? The s can hold 2, the p's can hold 6, the d's can hold 10. I guess what's next is 14. Okay, there's 7 different f orbitals, 2 in each. That's 14. All right, so we got that. Let's see. Let's count these up. Do we have, how many electrons do we have so far? 16 plus 54. We have 80. So we still need 2 more to get to 82. So now we're right here. No, we're not. We got 16 plus 54 is only 70. So we're still short, and that's because we didn't include these electrons. So what's next is the 5d10. Sorry about that. And then we would go right here, and it's 2 into the p, so it would be 6p2. Again, if you look at this, the p, the energy level of the p orbital is always the same as the row, the period number, you could say. So that's lead. Hey, all right. If we add that up, that should be 82. So we've got 26, 27, 28, plus 54, that's 82. Yeah, I'm sure it is. Okay, let's think about the lead ion. Lead has 2 ions, plus 2, plus 4. If we make it plus 2, we would get rid of these. Look at the highest energy level. We get rid of these, okay? And that's plus 2. If we make it plus 4, which 2, oh, look, we're not going to break into these filled orbitals. And, okay, we're going to have to break into this filled orbital. But look at that highest, that energy level, that's the 1. Those are the 2 that we're going to remove before we can remove these electrons from energy levels that are closer to the nucleus. So we'll just get rid of those, and that make it plus 4. And that's a nice little summary. You guys will need some practice doing this. Electron configurations. In AP, we always just use the noble gas abbreviation. These are the noble gases. S's can hold 2 electrons, P can hold 6, D can hold 10, F can hold 14. All right? I'd ask you if you have any questions, but I don't think you can respond to me. So this is a nice, I think this could help you. Maybe we could do one more. Let's do one more, okay? Let's look at indium right here. Indium has 49 electrons. Okay, so let me do that up here. Indium. What's the noble gas right before it? Indium. Right before it would be krypton. So this is indium, so krypton. I think krypton has 36 electrons. It does, 36. Okay, so let's start here. This is 5s1, 5s2. So we have 5s2. We're going to go through here, all the way through the Ds. 4D. Ds can hold 10. Now we're right there. We need to go here. And again, the P, it's the same energy level as the S. This is 5P1. All right? And if you add up 13 and 36, that's 49, and that's the atomic number of indium. So we're good to go. And if you look at indium, I think indium forms a +3 ion, that cation. And think about what 3 electrons you would take away. Which 3? Yes, you would take these away. That's indium +3. So, thanks. We'll see you again.